Hi, welcome to maths. Hope you're all very comfortable at home. It's nice and warm, got a cup of tea or something, ready to do some work. So we did 5A and B last lesson. With this lesson, we're going to look at C and D. So this is a simple title, just functions. So for each x value, there has to be only one corresponding y value. So let's look at an example of this. Here you can see that we've got a -4 here and a -4 here. So that is not a function because of those two and those two. This one here is a function. So we've got a -3, a -1, a -6 and a 1 as the x values. So each of them has a different corresponding y value. Vertical line test, you might have already looked at this, nice simple thing. So if you want to test whether or not something is a function, you can just draw a straight line, a straight vertical line through the graph. So let's have a look at one. So here we have the function y equals x squared. Question is state the maximal domain and the range. So if we draw a line through that, it only touches the graph at one point. And if we were to draw that line anywhere, it would only touch the line at one point. Therefore, y equals x squared is a function. State the maximal domain. So the domain of this is any x value. So the domain is R, and the range, as you can see, the range is just positive, but the positive including 0. So the range is all positive numbers, including 0. That one there, shout it out loudly. Looks like that one's a circle. There it is. Is it a function? Well, let's look. Let's apply the vertical line test. So if we draw a line down there, you can see that it's not a function. It crosses there and it crosses there. So it's not a function. Take care, because if you drew the vertical line here, it would just touch at one point, but it's got to be any point on the function. Or, sorry, all points on the function. There has to just be one place where it crosses. I love circles for their domain and range because they're nice and easy. The domain and range of that, so the domain, they're both the same, goes from -2 to 2, and the range goes from -2 to 2. Function notation. So this it's just a sort of thing so that wherever we are in the world, we can mathematicians can use the same language and they'll all know what they mean. So function begins with the letter F. So if we're writing off a function, starts off with F. If you go to your graphics calculator, whenever you draw a function on your graphics calculator, it has an F there, doesn't it? Next letter G and a H. So if you've got 3 different functions in the question, you've got a pretty tricky question there. So you're probably never going to go past 3 different functions in the same question. So y is called the image of x under the function f, so under f. So this is just language. This is just notation and language. You know it's just the x and y coordinates, but y is called the image of x under f. Or sometimes it's called the value of f at x. X is called a pre-image of y. So you can see kind of like the opposite, these two are the opposite of each other. Y is called the image of x. X is called the pre-image of y. We know that, but we call that f of x rather than y equals. So it's just, we're saying the same thing, but we're just using function notation to express it. So if we're writing that, we're just writing the graph. Here we've written it in the y equals notation. Here it's written in the f of x function notation. So there's no guessing, no clues or anything, no prizes for guessing what these are. So it's just the same thing written in function notation. Rewrite the following using the function notation. So we're saying that is a function, and we have all real numbers because they haven't given us a domain here. So the implied domain is all real numbers. We've just got f of x equals -3x plus 2. So nothing tricky there. This might be a bit of a weird bit, but again, it's just language, it's notation, nothing to be frightened of. B, so this bit here, f of x minus 2x plus 5. So that's the easy bit, yeah? That's the easy bit. Saying here that it's all values of x greater than and equal to 0. So this is saying that it's all real values, all real positive numbers, including, so union, including 0. Another way you can write it, of course, is to say that it goes from 0 to infinity. So from 0 to infinity. So those two things mean the same thing. It's good that you know both ways. C, so again, this bit here is just this bit here. It's the domain that we need to write in the function notation method. So it's going from -1 to 2. It includes -1 and it includes 2. So we have a square bracket there. You probably know that one already. This one here, so that's just the function. That's just the same thing written there. And it's any value apart from x equal to 2. So this is all real values apart from, so that backslash, apart from 2. So those two things are the same. So we're using the f, x, y notation, or just function notation. Restriction of a function. So we can see this is x squared, this is x squared, and this is x squared. It's just got a restriction on it. That's got no restriction on it, so it's just every real number. This one is just between -1 and 1, and this one is just all positive numbers, including 0. So that one's just got a restriction there, that one's just got a restriction there. We say that G and H are restrictions of F. Nothing tricky there. Sketch a graph of each of the following functions and state its range. So there's the first one. It's gone from -1 to 2, our x values. -1 to 2, those are our x values. So we've got to work out our y values. And because the function is just x, the x and y values are going to be the same. So here we're just substituting in, but because it's such a simple thing, when we substitute in, we get the same answer. Nothing tricky there. So the range of that one goes from -1 up to 2. So here the range and the domain are the same. Very rarely for that to happen. Let's have a look at B. So this is x squared plus x. So we would need to work out the intersects, all that sort of stuff in order to do this graph. We're assuming that that's already been done. So x values go from -1 to 1. So that coordinate's obvious because it's -1 along, 0 up. This coordinate here, so we just substitute in to find out what the value of the function is. So if x is 1, 1 squared is 1, plus 1 is 2. Now the range of this function isn't from here to here, is that we have to find the turning point. So we would have to put this into turning point form to find the turning point. So we can see that the x value of this is -1/2. So the lowest value of this graph is -1/2. The maximum value is 2. So sorry, it's -1/4. That's the x value is 1/2. The y value is -1/4. So this distance here is -1/4. So this one here goes from -1/4 to 2. See? So this would normally have another section here, wouldn't it? So this is a 1/x graph. It would normally have a section here, but because it just goes from 0 to 2, we're just drawing this peak. So it even makes the drawing of the graph even easier, really, doesn't it? Because it's just from 0 to 2, so we can work out the value of y when x is 2. So because it's 1/x, it's just 1/2, which is 1/2. So the range of this one, it goes from this value here all the way up to infinity. So it's 1/2 to infinity. This one here, again, it's a quadratic. We need to put it into turning form to find the turning point. It's all real values, so we know that the maximum value is going to be infinity. So it goes from 7 to infinity. Turning point form, 7 to infinity. There's some notes. Looking at D, a 1-to-1 function. So a function is said to be 1-to-1 if different values of x map onto different values of y. It's very similar to what a function is. So as we can see this one here, a function f is 1-to-1 if a doesn't equal b, implies that the function of a doesn't equal the function of b for all values of a and b. A 1-to-1 function cannot contain two different ordered pairs with the same second coordinate. So previously it was the same first coordinate, wasn't it? So a function, it was the same first coordinate. Here it's the same second coordinate. So second coordinate, second coordinate, second coordinate, second coordinate, they're all different. And when we look at inverse functions later on in this chapter, we'll need to know a little bit more about 1-to-1 functions. So which one of the following is 1-to-1? So let's say we've got a 4 there, 2 there, 3 there, 6 there, 4 there, 3 there, 2 there, 1 there. Not a 1 function, as both 1 and 3 map to 4. So we've got a 4 there and a 4 there. So those two y values, it says here, one-to-one function cannot contain two different ordinate pairs with the same second coordinate. So second coordinate of 4 there, second coordinate of 4 there. Here's a 1, got a 4 there, a 3 there, a 2 there, and a 1 there. They're all different. So that is a one-to-one function. To tell us something was a function, it was the vertical line test. Now we're looking at the horizontal line test. So that is not a one-to-one function. So y equals x squared is not a one-to-one function. If you think about it, most straight lines are all going to be one-to-one functions, aren't they? If we do the horizontal line test, it's only going to cross at one point. That one's a bit of a weird one because every single point on it, so definitely not one-to-one. Y equals x cubed just crosses at one point, so it is one-to-one. Semicircle or any type of circle is not going to be one-to-one. So if you draw a horizontal line, it crosses at 2 points. There's some notes for you, and there's loads and loads of questions. I've estimated that it will take you 433 hours to complete that work. Good luck.